At some point in your iOS journey, you'll work with APIs or external datasets. Most of these rely on JSON objects to store and transfer data. Understanding how to model these objects in your SwiftUI projects is critical. By doing this correctly, you'll be able to use and display the data in your apps. This video marks the official start of Section 2 in our SwiftUI beginner course. The main goal of this section is to fetch and display live data from the movie database API. We'll complete the first step in this video, modeling the JSON objects in our project. If you're just joining us, feel free to grab the Section 1 code from our GitHub. The link will be in the comments. I do recommend having some experience with SwiftUI before starting this section. Section 1 of this free course is a great place to start. Let's take a look at our API data. This set is for training movies. The data contains an object, as shown by the top left curly brace. This object has an end called page and an array named results. The results array contains the data that we're interested in. From here, we can pick and choose what is needed for our app. For Blossom Movie, we need ID, title, overview, and poster path. Just a heads up, I tried original title at first, but got titles in their original language, Spanish and Japanese included. Now that we know what data is needed, it's possible to build a model. I'll navigate back to Xcode, Command N to create a new file, Swift file, next, title, create, make some space after import foundation, struct, title with braces. Struct is short for structure in SwiftUI. It's a lightweight and efficient way to group related data together. Type var id :int, enter, var title :string, enter, var overview :string, enter, and var poster path :string. We model title based on what we need from the results array. Before moving on, please make sure your spelling matches with mine. Misspelling is one of the most common mistakes when working with APIs. I want to show you one more thing with our data. This next set contains training TV. Notice title has been replaced with name. ID, overview, and poster path are still here, but it's important to see the slight difference. Keeping this in mind, I'll go back to Xcode, hit enter after title, var name :string. This will allow our title struct to also work with the TV data. However, what happens if our app tries to find a title string for TV data? As we saw, title is replaced with name in that set. The app will unfortunately crash because it's expecting a value for title. To fix this, we can mark name and title as optionals by putting a question mark at the end. This tells our struct that title and name may or may not have a value. If they don't have a value, instead of crashing, the app will assign nil to them. Nil means no value in Swift. Because this isn't data that we manage, it's a good idea to mark all the properties as optionals, just in case. The properties we need from the results array are modeled well here. Just a few more things. After title, type : decodable, comma, identifiable. This makes the struct conform to the decodable and identifiable protocols. Decodable allows title to be created from an external data source. Swift will automatically map the data to the struct's properties if the names match. Identifiable requires this struct to have an ID property that uniquely identifies each instance. This will be useful when we use title in our SwiftUI views. Our title struct is complete. In the API data, title was under an array called results. We need to do the same thing with our title model. Make some space before struct API object :decodable with braces, var results : bracket title, bracket equals brackets. Instead of listing results as an optional, we set it as an empty array. That way, if the database returns nil, there's already an empty array there. I'll bring up the working data one more time and put it side by side with our model. Everything is matching up. We start with an array called results. This array contains a struct title, which has the properties we need. Good work on this one. This is a really important concept. It goes beyond iOS if you ever want to get into any other coding space. With our title model completed, we're ready to grab our API key. This key allows us to request and fetch data from the movie database API, after which we'll be able to display the data in our app. A quick word of caution. Safeguarding API keys is a broad topic that exceeds the scope of this course. While hard coding keys directly into your code isn't recommended, we'll take a simpler approach for this practice app by storing them in a JSON file. This method does keep the key out of the source code, but it's not a production level solution. However, it's a good step towards better practices. In addition, it'll also teach us concepts like the singleton design pattern and error handling. The first step is to get our credentials. Open a new Chrome window. Inside the search bar, type the movie database. The first link will do. Click on login. Please create an account if you need to. I already have mine, so I'll just log in. Select user profile, settings, API. This is where your API key will be. If you just made an account, you'll need to generate a key. It's a pretty straightforward process and totally free. Once you have your key, keep it handy. We'll need it here shortly. Navigate back to Xcode. Command N for a new file. Scroll all the way down. Empty. Next. API config.json. Create. Please make sure the file is inside your project directory. This file will hold sensitive information like our API keys and base URLs. In turn, this sensitive information will be out of the app source code. Inside the JSON file, start with an open curly brace and hit enter. This creates an object. Type quotes, tmdb, base URL, quotes, colon, quotes. I'll paste the base URL here. It'll be in the comments. Please copy and paste it as well. Close quotes, comma, enter. Quotes, tmdb, API key, quotes, colon, quotes. Paste your own API key here. As a placeholder, I'll type in your key. Before we move on, please ensure your spelling lines up with mine. Caps as well. Our API config.json file is ready to go. It just contains two strings, the base URL and our API key. Hit Command N, Swift file this time, next, API config, create. API config.swift will be used for reading and accessing the contents of the JSON file. This allows us to dynamically load sensitive information, like our API keys, into our app at runtime. Make some space after import foundation, struct, API config, colon, decodable, with braces. We have to include decodable because API config will be created by an external source, our .json file. Let tmdb base URL colon string, enter. Let tmdb API key colon string. These are the variables in our .json file. They have to match exactly. Hit enter a couple times. Type static let shared colon API config equals braces. At the end of the braces, put parentheses. We're using something called a singleton pattern here. This is a design pattern that ensures only one instance of API config is created. We're naming that one instance shared. Singletons are good for centralized resource management and usage. We know our logic goes inside the braces. The parentheses at the end are new. they immediately execute the closure at runtime. In turn, our credentials are available right away. Inside the braces, type guard let URL equals bundle.main.url. Select for resources with extension. In for resources, quotes, API config, tab, quotes, JSON, else, braces, fatal error, API config.json is missing or invalid. We're trying to find the API config.json file in the apps bundle. If the file isn't found, the else block executes and fatal error will crash the app. This ensures the app can't proceed without the JSON file. Make room after the closing brace. Now that we found our file, we can get the data out of it. Type do with braces. After the closing brace, type catch with braces. The do catch block is used to execute code that might throw an error. This allows us to handle that error gracefully if thrown. Inside the do block, let data equals try data contents of URL, return try json.decode API config.self, comma from data. Inside catch, fatal error, failed to load or decode API config.json \error. The autocomplete was pretty good here. Let's break this code down. Load the contents of the API config.json file from the URL we made above. Try is needed here because data contents of can throw an error. After that, try to decode and return the data as an API config struct. This is done using a JSON decoder. The catch block only runs if an error occurs in the do block. Again, fatal error is used because that app can't run without this information. To finish up, we need to run the app to make sure this works. Navigate to Content View. Double click on the tab view starting brace. Click on the closing brace. Enter. .onAppear with braces. Print API config.shared.tmdb base URL. Below that, print API config.shared.tmdb API key. Go ahead and run this code with Command R. If everything works, you should have the base URL and API key showing in your log. If your app crashed, please double check all the files we created. Misspelling and capitalization are the common mistakes. Right now, the app crashes if there's an issue with the .json file. In the next video, we'll explore a more user-friendly way to handle this error. Handling errors is a key part of your iOS development journey. Whether you're connecting to a backend or loading a JSON file, errors will definitely pop up. In this video, we'll refactor our code to gracefully handle errors. Currently, our file uses fatal error. This was good to help us understand how to load our API credentials, but it's not a long-term solution. Let's dive in and learn how to handle errors better. We'll start by creating a new file to keep all our errors organized. Hit Command N on your keyboard, Swift file, next, errors, create, make some space after import foundation, enum, API config error, :error, comma, localized error with braces. This is the first time we've seen an enum. Enums are used for grouping related values together in a way that's easy to manage and use. Think of them like a list of options or categories you can choose from. In this enum, we'll list all the possible errors related to our API config. We've also made our enum conform to the error and localized error protocols. Error allows the enum to be used for throwing errors in functions. Localized error enables us to provide more user-friendly messages or logs. This makes it easier to debug issues. These two protocols help our enum handle and describe errors in a clean way. Inside the braces, type case, file not found, enter, case, data loading failed, parentheses, underlying error, error, right arrow key, enter, case, decoding, failed, underlying error, error. These are the three issues that can cause errors in our API config file. The file isn't found, the data doesn't load, or there is a decoding issue. The data loading failed and decoding failed cases both include an underlying error. This is because these errors can occur for multiple reasons. For example, data loading failed might happen because the file is corrupted, or maybe the app doesn't have the right permissions to read the file. By including the underlying error, we capture the exact system error and use it for debugging. To finish the file, we can include user-friendly error descriptions. Hit enter a couple times after the last case, var, error description, hit tab to autocomplete. If we pause for a second, the editor will recommend finishing the property for us. Hit tab to autocomplete again. The editor did a pretty good job completing this property. Please make sure your file looks like mine. The error description string gives a better error description for each of our cases. When we get a data loading failed or decoding failed case, we include the error's localized description to see what went wrong. A quick note, the error description string is an optional because it conforms to the localized error, which is also an optional. Our API config error enum is complete, and now it's time to put it to work. Navigate back to api-config.swift. To start, let's organize the loading and decoding logic by placing it in its own function. After the parentheses, make some space, private, static, func, load, config, parentheses, throws, return arrow, API config with braces. A quick recap on functions. The private keyword restricts its function's access to only within the API config file. This ensures the logic for loading can be called directly from outside. Our singleton shared is static, which means it could be called anywhere in the project. Therefore, the function must also be static, since it'll be going inside the singleton. Load config is the name of the function. Throws allows the function to throw errors if something goes wrong, such as a missing file. Finally, the return arrow indicates the function returns an instance of API config once everything is loaded and decoded correctly. Next, let's move the loading and decoding logic into our function. Start from the last catch brace and highlight everything up until the guard statement. Command X to cut. Click inside our function and press Command V to paste. Replace the first fatal error with throw API config error dot file not found. In the catch statement, add let error as decoding error. Replace the second fatal error with throw API config error dot decoding failed underlying error error. We specify the error as decoding error to know exactly what went wrong with the decoding process. Decoding errors are really specific, and this helps us better debug if needed. Add another catch statement with braces. Inside type throw API config error dot data loading failed underlying error error. With this, we successfully integrate our enum to handle potential issues gracefully. Instead of crashing the app with fatal errors, we now catch and safely return descriptive errors. To finish this file, update our share singleton to be an optional. Inside the braces, write a do catch block. Inside do, return try load config. Try is needed because load config can throw errors. In the catch block, print failed to load API config error.localize description. After the message, return nil. This is why we made our shared singleton an optional. If there's an error during setup, shared will be nil, allowing the app to handle the situation without crashing. All that's left is to test. Go to our content view, delete the old print statements, type if let config equals API config.shared with braces, print config.api key, print config.base URL. Because API config.shared is an optional, we have to unwrap it to use it. Unwrapping means we check if it's empty or nil. The if let statement checks if it's nil, and if it isn't, we print the properties. Command R to run. If you're showing your API key with the base URL, everything went fine. But very quickly, let's simulate an error. Go to API config, and in the with extension argument, add an extra n. Command R again to run. This time, we're showing the error we defined. The API config file can't be found because the extension is mistyped. Most importantly, our app didn't crash. Very good. Please delete the extra n so everything works as expected. In the last lesson, we focused on handling errors gracefully to make our app more reliable. With that foundation in place, the next step is to start building functions that will decode our server data. To begin, head over to Content View and delete the onAppear block. This was a placeholder for testing and no longer needed. Next, navigate to our errors file. Here, we'll create a new enum to manage and categorize any network-related errors. Make some space after the closing brace. Enum, network error, error, localized error, brace. Inside the braces case, bad URL response, parentheses, underlying error, error, enter, case, missing config, enter twice, bar, error description. If your suggestion from the editor matches mine, press tab to autocomplete. Once again, the editor's autocomplete gives us the correct structure. Press tab to save some time. This is similar to our API config error enum above. The case bad URL response will trigger if the application encounters an issue with the server response. Some examples include a wrong website address, a server error, or a response that doesn't match the expected format. Case missing config triggers if something goes wrong with the configuration of our API config file. We'll need this when we unwrap our API key and base URL. By handling these scenarios, we ensure our app can gracefully manage unexpected issues during network requests. With our enum ready, we can make a new file to hold our network functions. Press Command N, Swift file, next, data fetcher, create. Our file is ready. Hit enter once after import foundation. Let tmdb base URL equals API config.shared.tmdb base URL. Enter. Let tmdb API key equals API config.shared.tmdb API key. We define the variables globally so that all of our functions can access them. Since the singleton API config.shared is optional, these variables are optionals as well. This ensures that if there's an issue decoding the API config file, our app won't crash, but handle the missing configurations. Hit enter a couple times after API key, func, fetch, titles, parentheses, for, media, string, close parentheses, async, throws, return arrow, bracket, title, bracket, braces, Let's break down this function. We know that fetch titles is the name. It takes one parameter, a string called media. The for in front of media is called an argument label. Argument labels make the function call more descriptive and easier to understand. We used for here, but you can use any word that fits your use case. Async throws means this function will run on a different thread than the main thread and might throw an error. This is important because as a network call, we don't want it running on the main thread with the UI. Doing so can lead to performance drops and a less responsive app. Finally, the return arrow indicates that this function will return an array of our title model. The purpose of this function is to connect to the URL and attempt to fetch the titles inside. The first step in this function is to build the URL where our data is located. To give you a better idea, I'll paste an example of what the URL should look like for trending movies. It starts with our base URL, followed by several directories, and ends with a query that includes your API key. To continue, we need to unwrap our TMDB base URL and TMDB API key. Inside the function, guard let base URL equals TMDB base URL else with braces. Inside the braces, throw network error dot missing config. Below that, guard let API key equals TMDB API key else with braces. Same thing, throw network error dot missing config. These checks ensure that TMDB base URL and TMDB API key are not nil. If they're available, they'll be assigned a base URL and API key respectively. However, if either of them are nil, the function will stop and throw the network error.missing config case. This will signal an issue with the configuration. With our base URL and API key values unwrapped, we can build the URL. Make some space, let fetch titles URL equals URL parenthesis string colon base URL question mark enter dot appending parentheses path quotes 3 / trending / parentheses media parentheses / day enter dot appending parentheses query items bracket enter URL query item name parentheses API underscore key tab API key. This builds the exact URL we have at the top. It adds the paths, including the media string and the parameters. Then, it appends the query items, including our API key as an argument. Query items are pairs of information added to the URL to send data to the server. Quick note, we use a question mark after the URL because the URL string initializer returns an optional. This means that if the string is invalid, the code will safely return nil instead of crashing. At this point, our URL is complete and ready to use. You've done an excellent job laying the groundwork for fetching data. In the last lesson, we started building our fetch titles function and created the URL containing trending movies. In this lesson, we'll complete the function by handling the API response and parsing the JSON data. First, let's fix a sneaky mistake in our URL. We forgot a / after trending. Without the slash, trending movie would be combined and the URL won't work. To help us debug when we run the code, add print fetch titles URL. This will print the URL in our console and allow us to inspect it. We do get a warning because fetch title URL is an optional. To safely unwrap it and handle potential failures, we need to update our network errors enum. Open the errors file. Inside network error, under missing config, case, URL build failed. After adding URL build failed, we'll see an error because any switch statement handling network error now requires this new case. Click on the error, fix. The code for our .url build failed can simply return failed to build URL. With our new case added, we can go back to data fetcher, add guard in front of let to safely unwrap our URL. At the end of the parentheses, else with braces. Inside the braces, type throw network error dot URL build failed. This ensures that if our optional URL is nil, we throw our new case, preventing potential issues down the line. We can finally start parsing this response. Make some space after our print statement. Let parenthesis data, comma URL response, parentheses equals, try, awaits, URL session, dot shared, dot data from, fetch titles URL. Let's break this code down. This function returns two values, data, which is the actual raw JSON data from the API, and URL response, a URL response object that contains metadata about the request. This could include an HTTP status code, which tells us whether the request was successful or not. These values are assigned to the variables data and URL response, respectively. Try is needed because this function can throw an error. For example, if the network is down. Await means this is an asynchronous operation, so the function completes in a separate thread without blocking the app. URL session is a built-in class in Swift that handles network requests. .shared is a singleton instance of URL session, meaning we don't have to create a new session manually. Finally, .data from fetch titles URL makes a network request to the URL we built earlier. It downloads the data from the API and also gets the response from the server. Next, we need to check if the URL response is valid. I'll scroll down and hit enter a couple times. Guard let response equals URL response as question mark HTTP URL response, comma, response dot status code double equals 200, else braces. We first check if the URL response above is a valid HTTP response. If it is, the HTTP URL response is assigned to response. Then we check whether our response variable has a status code of 200. A 200 status code means that everything went well and the request was successful. If either of these checks fail, we can throw network error dot bad URL response underlying error any error. Since we don't have an existing error to pass, we need to create our own using NS error. NS error stands for next step error, an Objective-C class used to represent errors in Apple's framework. Select the NS error that includes domain, code, and user info. We can put domain, code, and user info on their own line to avoid clutter. Domain represents where the error is coming from. In this case, parentheses data fetcher works because the error comes from this function. Code is the status code from the URL response. We can attempt to get this code using parentheses URL response as question mark HTTP URL response parentheses dot status code question mark -1. If a status code exists, we use it. If there is no status code found, we default it to -1, indicating an unknown issue. User info is a dictionary containing additional error details, such as a descriptive error message. We can use brackets and s localized description key, colon, quotes, invalid HTTP response. This ensures that if the response is invalid, we throw a readable error that helps identify the issue. I'll scroll down for more room. We check to make sure the response was valid. Now we can define our decoder. Click outside the guard statement, let decoder equals JSON decoder. A quick note, our variable poster path follows camel case, meaning the second word starts with a capital letter. In the API, they use snake case, meaning words are separated by an underscore, like poster underscore path. To account for this difference, we can add decoder dot key decoding strategy equals dot convert from snake case. This tells the decoder to automatically convert snake case keys from the API to camel case. Finally, we can complete the parsing. Type return try decoder dot decode API object dot self tab from data parentheses dot results escape. Since decoding can fail, we need to use try in case an error is thrown. The decode function takes an object type and tries to convert the raw URL data into that object. In this case, we're decoding the data as our API object struct. Remember that API object contains an array called results. This results array is made up of multiple title structs, where each struct represents an individual movie or show with its properties. By returning results, we get a fully decoded array of titles that we can now use in our app. I know this was a lot to take in, and some parts might have been a bit confusing. Feel free to rewind and revisit any explanation if you need to. Also, if you have any questions, don't hesitate to ask. I'll do my best to help. View models are a key concept, not just in SwiftUI, but across many frameworks. Their job is to handle data, while the UI focuses on managing the interface. Separating these responsibilities is a common practice and an essential skill for any developer. In this video, we'll demonstrate how to build a view model. The first step, of course, is to create a new file. Make sure to select the Blossom Movie folder, press Command N, Swift file, next, view model, create, hit enter for space. It's important that our view model instantly updates the UI whenever the data changes. Therefore, we need to include the @observable macro. @observable allows this view model to automatically notify the UI of any data changes. We typically can't use a struct with @observable because structs are value types. This means a new copy is created whenever they change. Instead, we can define our view model as a class. Now it can share and modify data without creating new copies. Inside our ViewModel class, we'll define an enum to represent the different stages of the fetching process. Enum, fetch status, with braces, case not started, case fetching, case success, case failed, parentheses underlying error, :error. Before making a request, we start with case not started, where the UI remains empty. Once fetching begins, the state switches to fetching, displaying a progress view. If fetching succeeds, we show the normal UI. However, if an error occurs, we'll display a view with the error message. With our enum created, we can now use it in the view model. Down arrow after the enum closing brace and hit enter. Private, parentheses set, parentheses var, home status, :fetch status equals .not started. Private set ensures that only the view model can update home status. Other parts of the app can only read its value. This is important because only view model will know the value for home status based on the response. We initialize it with .not started because no request has been made yet. The next step is to define our data fetcher. Before that, we need to navigate back to the data fetcher file and convert it into a struct. At the top after import foundation, hit enter, struct, data fetcher, open brace, scroll to the bottom and add a closing curly brace to complete the struct. This was something I forgot to do in the earlier video, and I apologize for that. The good news, you get to see how we fix mistakes in real time. With data fetcher fixed, we can return to our ViewModel file, press enter for a new line, private, let data fetcher equals data fetcher. A quick note, private isn't required here, but since no other file needs access to data fetcher, it's good practice to include it. That way, when we call structs in other files, we're only presented with relevant options. Next, we'll create an array to store our trending movie titles. New line, var, trending movies, colon, bracket, title, bracket, equals, brackets. The trending movies array will hold a list of title structs. We initialize it as empty to ensure our app doesn't break if no data is returned. With the properties set for now, we can move on to creating our functions. Make some space and add func, get titles, parentheses, async with braces. Async is used because this function will make a network call. This allows it to run on a separate thread, preventing it from blocking the main UI. At the start of the getTitles function, we could type home status equals .fetching. When this function is first called, it will allow us to display a progress view to show loading. Next, we can add a do catch block, since the function we're about to call can throw errors. Inside do, trending movies equals try awaits, data fetcher .fetch titles for movie. Remember, data fetcher .fetch titles returns an array of decoded title structs. We pass a string argument movie to build a URL for trending movies. This is useful because in the future, we'll need to fetch trending TV shows the same way. If this completed successfully, we can say home status equals .success. This tells our UI to show the home view. We just need to handle any errors. I'll scroll down first and add print error. This prints the error to the log for debugging. Now we set home status to .failed, passing error as underlying error. This gives us an error message that we can have the UI show. This is a simple view model, but we covered the core concepts of how it works. We just have a few more steps before we can see it in action, but we're almost there. InOut parameters are useful when you need to modify a value inside a function and have that change persist. Normally, function parameters in Swift are constants, meaning they can't be changed. With InOut, you can pass a variable into a function and have it change directly. In this video, we're going to apply this concept to complete our view model. Inside our view model right now, we're successfully getting the trending movies. However, each image from the API is only half complete. Let's jump into the constants file to see what's going on. The API only returns the last part of the image URL. To display the full image, we need to add the URL beginning part ourselves. We're going to create this InOut function inside our constants file. Let's first define the poster path beginning. I'll scroll down. I'll also make some room after test title URL 3. Type static let poster URL start equals tab. The editor might recommend it for you, but if not, you can just copy and paste it from above. We can delete the ending /. It's already included in the API response. Right arrow, hit enter a couple of times for space. Now we can define the function, static func, add poster path, parentheses 2, titles, colon, InOut, bracket, title, bracket, parenthesis, with braces. This function is static because we need another part of the app to access it. The function name is addPosterPath. We use the argument label 2, making it clear that we're adding the poster path to the titles. The titles parameter is an array of our title struct. The InOut keyword signals that this array goes into the function, gets modified, and comes back out with the changes applied. I'll scroll down a bit more. Inside the addPosterPath function, type for index in titles.indices with braces. This loops through all the titles in the array and gives us the index of each one, allowing us to modify them directly. Inside the for loop, add if let path equals titles bracket index.posterPath with braces. This checks if posterPath is nil. If it has a value, we assign it to the variable path and modify it inside the braces. Otherwise, we just leave it nil. We can finally complete the modification. Inside the if let statement, enter titles bracket index dot poster path equals constants dot poster URL start plus path. This takes the existing poster path, combines it with the base URL, and updates this value for each title in the array. Our function is complete. Let's use it in our data fetcher file. Scroll down to our return statement. Instead, type var titles equals. This stores the titles in an array, allowing us to modify it before returning the data. Now we can apply our InOut function to complete the poster path for each title before returning the array. Make a new line and add constants dot add poster path to titles return titles. The and before titles tells Swift modify the actual array, not a copy. This allows our function to apply changes directly, as we discussed earlier. We're complete with the InOut function, but we have time for one more thing. Navigate to our title file. We're going to create an array of sample data. This sample data will help us when we go back to the UI and work with our previews. Make some space after var poster path. Type static var preview titles equals brackets. Inside the brackets, type title. Down arrow to our struct. Right arrow. Select the one that has all the properties. This will ensure our sample data matches the actual structure of our API response. I'm going to space this out by pressing enter before title and after the closing parenthesis. This makes the code easier to read. Now copy this line. At the end of the line, type comma, enter, and Command B to paste. Do it one more time. This gives us 3 title structs to work with. We just need to fill in our data. It's going to be pretty simple. Just follow along. Click on the first ID. 1, tab, Beetlejuice, tab, Beetlejuice, tab, a movie about Beetlejuice, tab, constants dot test title URL. I'll do the same for Pulp Fiction. Start at ID, 2, Pulp Fiction, Pulp Fiction, a movie about Pulp Fiction, constants dot test title URL 2. Finally, we just need The Dark Knight, 3, The Dark Knight, The Dark Knight, a movie about the Dark Knight, constants dot test title URL 3. That wraps up this video. We learned about InOut functions and even got our sample data ready. I know we stepped away from SwiftUI for a bit, but in the next lesson, we're coming back with an important topic, the infamous, depending on who you ask, model view model, or MVVM pattern. The model view model pattern is a popular design choice for many reasons. It helps keep your code organized by separating UI logic from business logic, making it more maintainable and easier to test. Like most things in coding, it's a bit controversial, as some developers argue it's unnecessary in SwiftUI. In my experience, MVVM shines in complex projects, helping clean up loaded files and making code more structured and readable. Even though Blossom Movie is small, applying MVVM will give us experience, so you can decide if it's the right pattern for your own projects. To recap, our model is represented by the title file. This file defines the API object and is used for decoding our API response. There's also sample data to help us with our SwiftUI views. While we're here, it doesn't hurt to fix a typo. Moving on, we have the data fetcher file. This file acts as a service that holds our network logic. It contains the fetch titles function, which connects to our API, retrieves the data, and decodes it into a title array. Next, we have our view model. It includes an enum to track the fetch status, initializes the data fetcher, and stores an array of trending movies. Inside the getTitles function, it calls fetch titles to populate the trending movies array. Thanks to the @observable attribute, the view model automatically updates the UI whenever the data changes. To complete the MVVM pattern in this project, we need to connect the view model to our UI. First, open the horizontal list view file. Right now, it contains a static array of poster strings. Remove everything to the right of var titles. Replace it with : bracket title. This allows us to define a title array when calling this view, making it dynamic. We get a few errors, the first one being because we use .self as the ID in our for each loop. Our title struct already conforms to the identifiable protocol, so we can remove id.self. To fix the next error, use the title poster path property for the async image URL. Remember, all the title properties are optionals in case they're known in the API. Therefore, use a double question mark operator to provide an empty string if the value is missing. A default URL will be a better approach, but an empty string works for now. We have one more error in this file. The preview requires an array of titles to compile. Scroll down, click on the error, and select Fix. This adds the titles parameter, which we can set to title.previewTitles to resolve the issue. Our sample data coming in clutch. We're ready to go with this file. There are a few more errors to address, but before we fix them, open api-config.json. Replace your key with your actual API key from the movie database. I'll be doing this off camera, but please make sure to do this as the code won't work without it. If you need help getting your key, check out my API keys video for guidance. With that done, navigate to Home View. Under Hero Test Title, add let ViewModel equals ViewModel. This creates a new ViewModel that will control the UI. Press Enter after the scroll view brace. Type switch. Pause for a second to see if Xcode auto-completes it. If it does, press Tab to start the switch statement. Pause, then press Tab again to auto-complete the rest. It's always nice when Xcode helps us out. However, my switch statement isn't quite right. I need to change the third case to .success. For now, I'll leave an empty text in there. Next, I need to add the last case, dot failed, let error. Inside this case, I'll simply add text, error, \error. To break it down, we executed a switch statement on the ViewModel.HomeStatus When case is .not started, we show an empty view. With .fetching, a progress view appears. In .success, we currently have a text placeholder, but we'll add our UI here soon. Finally, in .failed, we display the error as a text on screen. Let's scroll down to fix the error that's showing. Click on the error and select Fix. This adds the missing titles array. Inside that, type ViewModel.TrendingMovies. Select the other 3 horizontal list views and comment them out using command /. We pass the ViewModel trending movies to our horizontal list view, which will display them. Although right now, the trending movies are empty. Now scroll up and double click on the lazy VStack brace. Reselect everything from the ending brace back to lazy VStack. Press Command X to cut. Inside the .success case, select the text and paste with Command V. If the case is .success, the UI will not be displayed. The last step is to make sure the ViewModel populates the trending movies array. Double click on Scroll View's open brace. On the closing brace, add .task, braces. Inside .task, type await, ViewModel.getTitles. The .task modifier runs an asynchronous task when the view appears, allowing await ViewModel.getTitles to fetch data without blocking the UI. This is the moment of truth. If your preview builds and you can scroll down to see the trending movies list, you're good. Scroll to the right and take a moment to appreciate how fast and smooth it scrolls. This whole section has been leading up to this moment. If you're not so lucky, we'll troubleshoot now. Press Command R to run the app. I got the simulator up and the list is working great. Open your log and the first thing to check is the API address. Copy and paste it to an empty browser window. You should see data returned just like mine. If you don't see data, check your API address to make sure it wasn't mistyped. Also verify that your API key is valid. You might also have configuration issues. Compare your code to the completed version to find any mistakes. Misspellings in the title struct or API config.json are also common issues. If you're not careful, a function can quickly get out of control, especially when you start reusing it for different tasks. To help combat this, helper functions in Swift can keep your code clean, organized, and easier to manage. We'll cover an example of using a helper function in this video to show how it can help simplify your code. Currently, we're fetching trending movies from our API using the fetch titles function. Since Trending TV has the same URL, the only change needed is swapping movie for TV. But we also need to fetch top-rated movies and TV shows. These calls have slightly different URLs, meaning modifying our fetch titles function. Let's open Data Fetcher and take a look. I'll paste the URL for top-rated media right after the training URL. The URLs are similar, with the main difference being the order of media and type. For example, the first URL uses trending/movie, while the second uses movie/top-rated. Additionally, trending includes day before the API query, whereas the latter places top-rated before the query. Since only the URL changes, we can keep the same function, add a parameter, and update the logic to build the appropriate URL. We could add that logic directly inside this function, but it will get big fast. Looking ahead, we'll also need this function for our search screen. Therefore, using a helper function now is a better approach. First, let's add the new parameter. After for media string, put a comma, add by type :string. This lets us specify the media as either movie or TV and choose between trending or top rated as a type. Now we can make our helper function. Double click on the fetch titles closing brace, add a couple lines, type private func build URL parentheses media :string comma type :string parentheses throws return arrow URL question mark with braces. We mark the function as throws, allowing us to throw error enums when needed. Inside the helper function, we need to unwrap base URL and API key. Lucky for us, this is complete already. Scroll up, cut the first two lines from fetch titles, paste them inside the build URL function, make some space, and add var path :string. This path will be used to construct the correct URL based on the type. I'll scroll all the way down for more room, add a couple lines, if type double equals parentheses trending parentheses braces path equals parentheses 3 / trending / parentheses media parentheses / day, else if type double equals top _ rated braces path equals parentheses 3 / parentheses media parentheses / top _ rated else parentheses throw network error .url build failed. With the path correctly made, we just need to build the URL. We got lucky again and already completed this. Scroll up to the fetch titles function and cut the guard let statement. Paste it under the else statement and build URL. Let's rename fetch titles URL to just URL. Also, replace the hard-coded path in .appending with our path variable. Below the guard let statement, add return URL. This completes the build URL function. Let's put this new function to work by scrolling up one more time. Before the print statement, type let fetch titles URL equals try build URL media type. We just need to unwrap since the build URL function returns an optional. Guard let fetch titles URL equals fetch titles URL else braces throw network error .url build failed. I'll fix our spacing. That completes our fetch titles function, allowing it to fetch both trending and top rated titles. Without the build URL helper function, this logic would stay inside fetch titles, making it messy and harder to maintain. Please try to use helper functions whenever they make sense. To wrap this up, go back to ViewModel, add the missing parameters for our fetch title call. We can put parentheses, trending. When making multiple async calls, using try await for each one can slow things down. This is because each call must finish before the next one starts. To improve speed, we can use Async Let, allowing each call to run parallel instead. In this video, we'll demonstrate how to implement Async Let using Blossom Movie as an example. Our view model currently only fetches training movies. We still need to get training TV shows, top-rated movies, and top-rated TV shows. The hard part is already done, since our fetch titles function is set up to handle different URLs. Now we just need to put it to work. We can start by defining our new arrays, make a line after training movies, type var, trending, TV, colon, bracket title equals empty brackets, enter, var, top rated, movies, colon, bracket title equals empty brackets, enter, var, top rated, TV, colon, bracket title equals empty brackets. Like the training movies, we create these lists as empty in case the API returns them null. Next, scroll down and press enter after the try await closing parentheses. We'll call data fetcher to populate our new arrays at trending TV equals try await data fetcher dot fetch titles for TV by trending top rated movies equals try await data fetcher dot fetch titles for movie by top underscore rated top rated TV equals try await data fetcher dot fetch titles for TV by top underscore rated. From here, we can open home view, go down, uncomment the horizontal list views by selecting them and pressing command /. Errors appear because we need to pass an array for the different views. Click on the first error and press fix. Add view model dot trending TV. Click on the next error and press fix. Add view model dot top rated movies. We just need the last error. View model dot top rated TV. Our preview updates, and if we scroll down, the rest of our titles appear. We've put in some work, and our app is pretty well organized, making this addition seamless. Press Command R to run the code. Scrolling down to the right, all the titles load pretty quickly. I'm going to close the app a couple of times and reopen it to test loading speed. Not gonna lie, it's actually pretty fast. Keep in mind this is a small app with only 4 network calls going so far. As we add more to it, it might slow down with our current async setup. Let's see if we can improve it by going back to view model. I'll close the log. Right now, we're using try await for each call. This means training movies runs first, training TV waits until it's done to start, and so on with the other calls. To speed things up, we can use Async Let. Starting with training movies, highlight everything to the left of data fetcher, replace it with Async Let T movies equals. We can do the same for training TV. Async Let T TV equals. Moving on to top rated movies. Async let tr movies equals, and finally async let tr tv equals. Now we can update trending movies to try OAT movies, training TV to try OAT TV, top rated movies to try OATR movies, and finally top rated TV to try OATR TV. By using Async Let, the calls run in parallel instead of each one waiting for the previous one. Press Command R to run the app. We have our app ready. I'll do the same test a couple of times, closing the app and reopening it. The app is slightly faster, but as mentioned, this could really make a difference with more network calls and a bigger app. API network requests are one of the most performance taxing and expensive things your app can do. It's important to think about how often you need to make a request and adjust your code accordingly. In this video, we'll rethink how our app is conducting calls and modify it to fit the correct profile. In our ViewModel class, we have our getTitles function retrieving our data from the API. The issue is that the titles are retrieved even if the list is already populated. This results in more network calls than we need since our data doesn't update consistently. If this was a chatting app, it would make sense. Let's run the code to see. We can scroll down to see the titles populate. If we change the tab to upcoming and go back to home, the view is back to the top. This is because the getTitles function repulled the titles. With this API, it's unlikely the data changes that fast. When the user opens the app, populating the titles there is enough. We can fix this in our ViewModel class. Scroll down. Right after home status equals .fetching, make a new line. If trending movies is empty, open brace, scroll down to the catch statement, enter, add a closing brace. This makes sure the API is called only if trending movies are empty. Type else with braces after the if statement. Home status equals .success. This lets our ViewModel know that the lists are populated and to set the UI normally. Hit Command R to run. Now scroll down to load the titles. Press upcoming and go back to home. The titles didn't repopulate, making our API calls more efficient. It's a good idea to think about the calls you're making and how you need them. There's one thing left before wrapping up. Go back to the ViewModel. Make sure you're inside the isEmpty block. Change the home status to fetching. This will keep the UI loading. Run the code. The progress view is sitting in the corner looking odd. To fix it, open Home View. Select Progress View. Add the .frame modifier. Width and height. Set the width to geo.size.width. Tab geo.size.height. Run. Much better. Let's reset our status to .success in the ViewModel. Run the code one more time. This is a big moment. Section 2 of the course is officially completed. We've been uploading this section for about 2 months. I want to thank you all for the support. It really means a lot to us. Section 3 will cover navigation. Can't wait to see you there.